another problem which comes initially when you try to scale your system. Okay, so hello everyone, this is the new video where we'll be unjagging the term load balancer. And yeah, it is a very primitive, very initial concept we get to know when we are exploring the distributed systems. So as we know, like, until we go to the distributed systems, the problem work less. Okay, in the monolithic architecture, you not need to know the more terms, the many concept. But as you hit the distributed system, you need to know many more things because the new problem and many problem will arise. Okay, so in one of the last video, we talked about the stateful and stateless architecture, and that is the problem we get to solve in the yeah. So yeah, this is the another problem which we so yeah, this is another term load balancer which solve the specific problem in the scaling world of the distributed system. So before actually knowing what load balancer is, first know that what is the problem we have and how load balancer proposed to solve that problem. So the problem was, as you scale, as we know, we need to check the bottleneck, like where our system is initially our bottlenecking, where its system fails because we have a pipeline kind of thing in our backend services, backend server, which is user first hit something like a domain or an IP, then it goes to a web server. Okay? Web server is responsible to entertain those requests and do the particular task like processing or the database call and get the data from the database, process it and return it. Okay, whatever the request, it could be anything. So sometimes the bottleneck is happening at the request entertainment end. Like web server is not able to handle enough requests. In the previous video or in the rate limiter, if you know that we handle those kind of heavy usage by balancing the load, you just not accepting the request more than an amount in an period of time. So that solve the problem by discontinuing the service, or you just throw an error to the user and the client and that yeah, we are not able to process further more request. So this might useful sometimes for some cases, but yeah, as you scale, there might be cases where you need to make your server up all the time, no matter how much request came. You eventually your server or your website or your application grows and popular and get viral, then it is organic engine meant to get it more load, more request like over time. So yeah, the rate limiter will cut down the fishy attacks or the unusual spikes in the request, which may lead to the downtime and other thing. The rate limiter will solve that problem. But what happens when your requests genuinely increase and your server is not enough capable to entertain those requests? Yeah, generally you have a 1 lakh users, okay, or 100,000 user in the other terms, and your server is just simply not enough to handle those genuine requests, genuine 100,000 users. So what you do in that case, you can't just simply cut down and let them wait to wait for hours and wait then, because if you have capacity of like 100 users at a time, then those rest of the users need to wait a long time. So simply it's just increase the CPU capacity until you can't. So what problem is that, like, a single server cannot be scaled infinitely, so you need to have multiple servers. Multiple servers means you have multiple CPU processor servers proper with the RAM, with the storage, everything. So now in the monolithic, in the earlier word, your request just first came to the server, with the web server, and which do the rest of the thing, connect the database, entertain and fulfill all those things which is asked in the request. But if you have two servers, because you want more power, more capacity to hold more requests or entertain more requests, but how client will know like for which server is free to connect, like because you added two servers, so eventually you expect like half traffic will go in the this server and half traffic go to that server or whatever the proportion you decide. So how the server know, like, because the domain would be all same for all the users. Like if it is a google.com, it is safe for all the users. So either you, every time you add a new server, you market or popularize on social media, or anywhere in the market, you propose a new domain. Like, yeah, for some users, this domain will work like google3.com, google2.com, and that will be, the mess, the unpractical or unscalable, inscalable, like, process. So, and it is bad user experience as well, because user cannot remember so much of things. So what you do, you make a master server. Master server means a big controlling server which only need to take care the routing, like this request will go to which server internally. So instead of one more, we need to have at least two servers, or one can do the routing part, which will be explaining now, which is the load balancer. So load balancer is just a program which can be set on a one server, or it can be have a standalone server. Task that the problem it solve, it's just the routing problem. The end users will no feel nothing difference. It will stay the same google.com, or simply any application URL, it will hit. The routing part, the load balancing part, the load which is heavy coming, like 100,000 users are accessing the server. The load balancer is a program which do the math, divide those requests into the 1 by 2, or depending on the server, 1 by 3, 1 by 4, and distribute the request around the servers. So what it does, it's like request coming, then a load balancer, and then distribute to the further servers. Okay. So load balancer could be another dedicated server which could do these things. It is also called a proxy, we say, and in other terms, proxy we will be discussing in a separate video, because itself it's as argument term. But yeah, the load balancer, what is thing, it is balance the load. It is just a simple task to do, like how to balance the load, and it is responsible for that. Okay. So eventually your problem gets solved. The load balancer will only your and all the user will hit the load balancer only, and from that, load balancer is not a web server, so it will not do anything other than rerouting those requests to the dedicated server. Okay. So suppose you have two servers or three servers, then load balancer get the request, it will divide in 1 by 3, 1 by 3, and reroute the script. Just copy the same request and forward it to the main server, which will handle this request. So if new servers get added, then you just need to ask the load balancer, yeah, just add also let your service server also some request. If server has got down, then you have some server still handle to the request. Yeah, your service, your website becomes slow, but it will not go down. Earlier, if you have only one server, if it goes down, then whole system goes down, then the experience is bad. And the little thing is also came that for the system to be, the scalable horizontally, if you want to have more servers, then your request must be stateless, in which we talked about in earlier video. Stateless means, simply, you do not want any session to store at the server, because the load balancer will not care, or it will, the you know kill the purpose of distribution, because if your request will go to the same server every time, because you because of the session, then that request will not get distributed, and a dedicated server will be exploited. And if many users, because it will apply to the all user, if they subscribe or if they store the session in a one server, then they need to go to that server every time, and those requests, those thousands of requests, cannot be distributed among the multiple servers. And that is the problem. Comes with the solution, load balancer or the horizontal scale, like finds a solution, then opens a new universe of the new problems, and which is not bad, but we still need to think about all those. Okay. So yeah, so to efficiently use the load balancer, we need to have stateless or sessionless, the architecture, the authentication process, the authorization process. It is need to be stateless. In at least in a typical load balancer, or horizontal scaling problem. Okay, that's it from this video. Hopefully you will get some idea about this, and if you have any question, maybe you can comment down below. If some word you want to be unjargon, then you can comment that below as well, and I will be try to answer that. Yeah, thanks for watching.